So, you've probably heard the term GUI thrown around, maybe in a class, maybe online. It stands for Graphical User Interface, but what does that actually mean? Put simply, it's the reason you can point, click, swipe, and interact with your devices using visuals instead of just typing out lines of code. It's the friendly face of all the complex stuff happening behind the screen. If you've ever used a smartphone, a laptop, or even an ATM, you've used a GUI. It's the collection of icons, buttons, and windows that make technology intuitive and accessible to pretty much everyone. Think of it like this. Interacting with a computer used to be like ordering from a restaurant where you had to know the exact, specific name of every single ingredient and tell the chef precisely how to combine them. That's a command line interface. A GUI, on the other hand, is like being handed a menu with pictures. You just point at what you want. The cheeseburger, the fries, the soda, and you get it. It's visual, it's simple, and you don't need to be a master chef or a programmer to get what you want. It's a massive leap in usability. This video is really for anyone curious about the fundamentals of how we interact with our tech, but it's especially geared towards tech students who are just starting to peel back the layers of the digital world. We're going to break down what a GUI is, look at its key components, how it works under the hood, and weigh the pros and cons. We'll cover everything you need to know to get a solid handle on one of the most important concepts in modern computing. So, let's get into it. Alright, so let's properly define it. A GUI, or Graphical User Interface, is a type of user interface that allows people to interact with electronic devices through graphical icons and visual indicators, as opposed to text-based interfaces, typed command labels, or text navigation. Before GUIs became the standard, using a computer meant staring at a black screen with a blinking cursor. You had to know the exact commands to type to make the computer do anything. It was powerful, but not exactly welcoming for the average person. The GUI changed everything by putting a visual layer, a friendly face, between the user and the complex code running the machine. Let's stick with that vending machine analogy, because I think it works really well here. Imagine you want a snack. With a command line interface, or CLI, you'd have to walk up to a blank machine and type something like execute get underscore item, row =, B, call =, 4, payment =, 1.50. You have to know the exact syntax, the item code, everything. One typo, and you get an error message instead of your chips. It's efficient if you know what you're doing, but the learning curve is steep. Most people would just walk away hungry. Now think about a modern vending machine. That's the GUI. It has pictures of all the snacks. You see the bag of chips you want? You press the button right next to it, B4, and the machine does the rest. It's intuitive. The buttons, the pictures, the slot for your money, it's all part of a visual system designed to be as easy as possible. You don't need a manual. You just look, press, and get your snack. That's the core philosophy of a GUI, to make complex operations simple and visually intuitive for the user. So what makes a GUI a GUI? There are a few key features that are pretty much universal. First and foremost, you have the graphical elements themselves. These are the building blocks of the interface. The icons that represent files and apps, the buttons you click to confirm an action, and the windows that contain and organize everything on your screen. Instead of abstract commands, you get tangible, visual objects that you can directly interact with. It's the difference between reading a description of a tool and actually seeing the tool right in front of you. Next up is the interaction method. GUIs are designed to be used with pointing devices. The mouse was the original game changer, allowing users to move a cursor around the screen and click on those graphical elements. Today, that's expanded to trackpads, styluses, and of course, our own fingers on touchscreens. This direct manipulation is key. You can physically, or at least digitally, grab a file and drag it into a folder. This creates a much more direct and engaging connection between the user and the digital environment, making it feel less like commanding a machine and more like working in a digital space. Finally, there are two more big ones: a multitasking environment and a user-friendly design. GUIs, through the use of windows, allow you to have multiple applications open and visible at the same time. You can write an email in one window while a video plays in another. This visual representation of parallel processes is something a simple command line struggles with. And all of this ties into being user-friendly. The whole point is to lower the barrier to entry. The visual cues, the intuitive actions, the forgiving nature of it, it's all designed so that someone with zero programming knowledge can sit down and start using a computer effectively within minutes. Let's break down the main components you'll find in almost any GUI. First, you have icons. Think of these as little pictures that act as shortcuts. The trash can icon for deleting files, the folder icon for, well, folders. They're visual metaphors that tell you what something is or does without you having to read a label. It's like road signs. A picture of a bicycle tells you it's a bike lane instantly. Windows are next. These are the rectangular areas that frame your applications. They're like separate desks in your office. You can have your documents on one, your web browser on another, and you can move them around, resize them, or stack them to organize your workspace. Then you have menus. These are lists of options, commands, or actions that are typically hidden until you click on something like File or Edit at the top of a window. It's like the table of contents in a book. It gives you a structured overview of everything you can do without cluttering the main page. Alongside menus, you have buttons. These are the clickable elements that trigger a specific action, like save, cancel, or submit. They're the digital equivalent of a light switch. You press it to make something happen immediately. It's a clear call to action, and you can't forget the supporting cast. Scroll bars appear when there's more content than can fit in a window, letting you move up and down or side to side, like rolling a long scroll of paper. Dialog boxes are those little pop-up windows that appear to ask you a question or give you important information, like, "Are you sure you want to delete this file?" They demand your attention for a critical decision. And finally, you have the cursor or pointer. This is your hand inside the digital world, controlled by your mouse or trackpad, showing you exactly where you're pointing and what you're about to interact with. So, how does all this pointing and clicking translate into actual work getting done by the computer? It's a fascinating layered process. It all starts with the operating system, or OS. Your OS, whether it's Windows, macOS, or a Linux distribution, provides something called a GUI toolkit, or a windowing system. This is basically a pre-built library of all the graphical elements, the buttons, the text boxes, the windows, that developers can use to build their applications. This ensures that apps have a consistent look and feel across the system. It's why a close button generally looks and works the same way in every app. When you, the user, perform an action, like clicking the mouse or tapping the screen, the hardware sends a signal to the OS. The GUI layer of the OS then has to figure out what that signal means in context. It asks questions like, where was the cursor when the click happened? Was it over a button, an icon, a draggable window title bar? Based on the answers, it translates your simple physical action into a specific command that the system can understand. So a click on a save button becomes a command to the system to write the current data to the hard drive. This interaction happens through the kernel, which is the core of the operating system. The GUI sends the translated command to the kernel, which then executes the low-level task, like managing files or allocating memory. Once the task is complete, the kernel sends a confirmation back up to the GUI. The GUI then updates what you see on the screen to reflect that change. If you drag a file into the trash, the GUI tells the kernel to move the file data, and once it's done, the GUI updates the display to show the file icon is now gone from the desktop. This constant back and forth loop is what makes the interface feel responsive and, well, live. The best way to understand GUIs is to look at the ones we use constantly. The most dominant one in the world is, of course, Microsoft Windows. From the Start menu to the taskbar and the File Explorer, its entire design is a GUI built around windows, icons, and menus. It's the default for a huge number of PCs and laptops, and for many people, the Windows desktop is what they picture when they think of a computer. It has evolved a ton over the years, from the blocky look of Windows 95 to the sleek modern design of Windows 11, but the core principles have remained. On the Apple side of things, you have macOS. It's another prime example of a powerful and polished GUI. It popularized many concepts we now take for granted, like the desktop metaphor, the menu bar that's always at the top of the screen, and the dock for quick app access. macOS is often praised for its clean aesthetic, smooth animations, and consistent design language across its applications. It's a different philosophy from Windows in some ways, but it's still fundamentally a WIMP interface designed for ease of use. And it's not just the big two. The world of Linux has a ton of different GUIs, which are called desktop environments. Popular ones like GNOME and KDE offer highly customizable and unique user experiences. GNOME is known for its minimalist, modern, and workflow-focused design, while KDE is known for being feature-rich and highly configurable, looking a bit more traditional. And of course, we can't forget mobile. Android and iOS are the GUIs for billions of smartphones. They are touch-first GUIs, designed from the ground up for taps, swipes, and gestures on a smaller screen. Every app you open, every notification you swipe away, that's you interacting with a masterfully designed mobile GUI. So there's a reason GUIs are everywhere, and it comes down to a handful of major advantages. The biggest one is simply that they are easy for beginners to learn and use. You don't need to go to a class or read a thick manual to start using a computer with a GUI. The visual nature of it allows for discovery. You can click around, explore menus, and figure things out on your own. This accessibility is what took computers from a niche tool for experts to a universal device for the masses. It democratized computing. Another huge benefit is that you don't need to memorize a long list of complex commands. With a command line interface, you need to know the exact syntax for every single operation. Want to copy a file? You need to know the cp command and its parameters. With a GUI, you just click and drag the file, or right-click and select copy. It's less mentally taxing and reduces the chance of errors from typos. This visual process representation makes tasks more intuitive and less abstract, which is how most people prefer to work. Finally, GUIs are just better for certain kinds of tasks. They are incredibly efficient for multitasking, letting you arrange multiple windows and easily switch between them. They are also far more attractive and engaging to look at and interact with than a wall of text. And with the rise of smartphones and tablets, the principles of GUI have evolved to perfectly support touchscreens. The ability to directly touch, pinch, and swipe the elements you want to control is a direct extension of the GUI philosophy, making the experience even more intuitive and physical. Now, it's not all perfect. As great as GUIs are, they do come with some notable disadvantages, which is why command line interfaces are still very much alive and well, especially among developers and system administrators. The biggest drawback is resource consumption. All those graphics, animations, and background processes that make a GUI look nice and feel responsive require a significant amount of the computer's processing power, CPU, and memory, RAM. A simple server running only a command line can operate on very minimal hardware, while a full desktop GUI needs much more power to run smoothly. Another issue is that for all their user-friendliness, GUIs can be more complex to design and program. Creating an intuitive, good-looking, and responsive graphical interface is a huge amount of work for developers. They have to consider layout, user experience, different screen sizes, and more. A simple command line tool, on the other hand, is much faster and simpler to create. It focuses purely on function over form, which can be a huge advantage when you just need to get a specific job done quickly without all the visual overhead. Finally, and this might sound counterintuitive, for certain advanced tasks, a GUI can actually be slower and less efficient than a CLI. Imagine you need to rename 1,000 files in a specific way. In a GUI, you'd have to click on each file, select rename, type the new name. It would take forever. With a command line, a pro user can write a single short script that does the entire job in seconds. For repetitive tasks, automation, and having fine-grained control over the system, the command line is often the undisputed king of speed and power for those who know how to wield it. So there you have it, a deep dive into the graphical user interface. At the end of the day, the GUI is arguably one of the most important innovations in the history of personal computing. It's the bridge that connects us, the human users, to the incredibly complex machinery of our devices. By translating complicated commands into simple visual actions, GUIs have made technology accessible to billions of people, regardless of their technical background. It transformed the computer from a tool for a select few into a universal appliance for communication, work, and creativity. The next time you unlock your phone, open an app, or drag a file on your laptop, take a second to think about the interface you're using. Notice the icons, the placement of the buttons, the smoothness of the animations. You interact with these carefully constructed digital environments every single day, and they shape how you work and play. It's easy to take them for granted, but every element is the result of decades of design evolution, all with the goal of making your life easier. It's pretty cool when you stop to think about it. It's the silent partner in almost everything we do with technology. From Windows to iOS, from GNOME to the dashboard in a Tesla, GUIs are everywhere. I'm curious to hear your thoughts. What's your favorite GUI to use and why? Or maybe you have a better analogy for explaining what a GUI is than my vending machine one. Let me know down in the comments below. It's been beta_test. Thanks for watching, and I'll catch you in the next one.